Hello everybody, Kemo Sabi here, coming at you with another video. This one's off of nytimes webpage, the New York Times. A write-up by Janice Brahney. Dr. Brahney is a biogeochemist at Utah State University, published on June 25th of 2020. You're probably inhaling microplastics right now. A new study found plentiful evidence of teeny particles in the dust in the nation's most remote places. Logan, Utah. We weren't looking for what we found. My researchers group was trying to determine how much phosphorus was being carried by wind and rain into some of the most remote regions of the West, and how this nutrient might affect lakes and streams. To do so, we sampled dust in 11 scattered locations, from Joshua Tree National Park in California to the Wind River Range in Wyoming. Back at the lab, peering through microscopes at our samples, we could see pollen, insect parts, and bits of minerals, all of which would have made it just another day in the life of a dust scientist. But what made it different was an unexpected interloper, teeny bits of plastic, most from synthetic microfibers used for making clothing. They're in all of our samples, and lots of them. There was so much microplastic, we calculated that up to 6% of the dust in those far-flung locations are microplastics, and that more than 1,000 metric tons are deposited in those places every year by wind and rain. Some blew in from nearby cities, but most came from much further away and represented decades of plastic waste. 4 colleagues and I recently published our findings in the journal Science. This waste has become so ubiquitous that it's now in the air we breathe. Airborne microplastics don't care what zip code you live in. Preventing a landfill in your community won't limit your exposure, and there are still many questions. If dust in the Grand Canyon contains microplastics, how many of these teeny plastic particles are in city dust? How high will airborne concentrations of microplastics get? What effect are they having on the environment? Are microplastics more toxic than other, better understood sources of air pollution, such as natural and industrial dusts? We know that inhaled plastics can produce inflammation and lesions in lungs, and repeated exposure is suspected to leading to respiratory problems like asthma and cancer. Inhaling microplastics may also increase exposure to other toxic substances and coatings associated with plastics and their manufacture. Natural dust, which includes dust generated by humans, and industrial dust can also contain dangerous components like the pathogen Coccidiosis, a soil-borne fungus that causes valley fever, which can produce flu-like symptoms. Industrial, urban, and agricultural dusts often contain heavy metals as well as synthetic toxins. Outdoor air pollution causes roughly 7 million premature deaths a year and is associated with pulmonary diseases. Even when adjusted for underlying risk factors, those statistics most likely include some of the effects of plastics. That we can breathe in microplastics has been known for decades, we just haven't fully appreciated the scale of the problem. But as Steve Allen, who does research on microplastics at the University of Strathclyde in Glasgow, Scotland, put it recently to the Washington Post, it is hard to imagine a sentence starting with the health benefits of breathing airborne microplastic. We shouldn't be surprised by these findings. In 2018, about 359 million metric tons of plastic were produced worldwide. Plastics are useful, of course. We need them for medicine, food safety, and technology. But do we really need plastic lawn decorations for every holiday? The plastic pollution crisis seems to have as much to do with industry as it does with consumer choices. A 2017 study in the journal Science Advances estimated that if current production and waste management trends continue, roughly 12 billion metric tons of plastic waste will be in landfills or in the natural environment by 2050. Movements against plastic pollution has led to bans on plastic straws and plastic bags, and microbeads in cosmetics. But airborne microplastics mostly come from clothing, car tires, and fragmentation of commodities and packaging used briefly and then thrown away, sometimes decades ago. Reducing plastic waste means taking aim at consumer comfort and convenience and offering sustainable alternatives to plastic for those on all rungs of the economic ladder. The path forward to cleaning up this problem is not clear, but undoubtedly will require sweeping and uncomfortable changes. Taking on this issue requires understanding it, and as our findings underscore, one thing is clear: we're breathing in microplastics. That can't be good. Janice Brahney is an assistant professor of watershed sciences at Utah State University, where she directs the environmental Biogeochemistry and Phaleolimnology lab. The Times is committed to publishing a diversity of letters to the editor. We'd like to hear what you think about this. Any of our articles here are some tips, and here's the email, letters at nytimes webpage, and follow the New York Times opinion section on their Facebook, Twitter at nyt opinion, and Instagram. And a version of this article appears in print on June 26, 2020, Section A, page 27 of the New York edition, with the headline, "We're all inhaling microplastics. Order reprints today, paper, and subscribe." So, hopefully you enjoyed the write-up, everybody. It'd be awesome if you hit that likes up. Wicked if you subscribe, and awesome if you leave me some comments. Peace. Roll till the wheels fall off. Thanks, everybody. We'll see you in the next one. Bye.